So in this video, we're going to look at the question C of question 3 in 2023 round 1 section 2. So it says Charles and Robert's brother's balloon flew not long after but was filled with hydrogen. So linking the previous question, I suppose it changed from hot air to using hydrogen, and then the balloon worked. So then and then it gave us the capacity of the balloon, which is 380 cubic meters, and was filled on the ground at a sea level pressure of 1.01 times 10 to the 5 pascals and temperature of 288 kelvins. And first part wants to calculate the mass of hydrogen in the balloon. So I suppose the mass of hydrogen can be determined using the ideal gas equation. So PV is equal to nRT, and we're given the pressure is 1.01 times 10 to the 5. The volume is given as 380 cubic meters, and it is equal to the number of moles times 8.314, the gas constant, times the temperature, which is given as 288 kelvins. So therefore, we can calculate the number of moles, which is equal to the mass over the molar mass. And for hydrogen, it's basically H2, so therefore the relative molecular mass should be 2, and then it is equal to whatever that is. So over here it should be 1.01 10 to the 5 times 380 over, this is 8.314 times 288, and that gives us wait, that is a very large number. Okay, so it should be let me check if there's any kind of problem over here. And PV is equal to nRT. Yeah, okay. And then so okay, that makes sense because this should be in grams. So therefore, the mass of hydrogen should be equal to this times 2. This times 2, which is, if we round it to kilograms, it should be 32.058 kilograms. And that should be the answer to the question. And the second part, let me see. So it says the balloon was constructed of a single lamina of rubberized silk with a thickness of 0.43 milliliters. The silk cloth has a mass per unit area of 66.5 grams per cubic meter and a density of 1.3 grams per cubic centimeters. And then rubber has a density of 1.3234. Assuming the balloon is spherical, calculate the mass of the balloon to 3 significant figures. Okay, so how do we calculate the mass of the balloon? It gave us the unit area, mass per unit area of the silk, and mass per unit area of the silk, and then also the rubber. Wait, it's a construction of single lamina of rubberized silk with a thickness of this. Okay, so okay, so basically using the mass per unit area and the density of the silk, we can calculate the area of the balloon, which we could utilize it to get the mass of the rubber. Okay, so the mass per unit area. It's given that the thickness is 0.43 milliliters. I think one way to do this is that what we know is that 66.5 is equal to the density, which is 1.3 multiplied by the thickness. Okay. 1.3 multiplied by thickness. Now in this case that's per cube, so therefore you have to multiply it by 10 to the 6th. To get it into cubic meters, and then it's multiplied by the thickness of the soap. So the thickness of the soap should be equal to 66.5 divided by 1.3 and then times 10 to the power of 6. No, that is so that is like 0.051 millimeters, and yeah, so therefore the thickness of the rubber should be equal to this minus that should be around like 0.379 millimeters, and then we can calculate the area. It didn't give us the area. Then how do we calculate the mass? Because we're given the unit area and oh, okay, we're given a volume, so yeah, we can just calculate that. So and then so therefore the mass per unit area for the rubber should be equal to 1.34 times 10 to the 6th and then multiply by 0.379. And that is equal to that's a rather large number. Wait, let me check. Oh yeah, we have to multiply by, because it's in millimeters. So yeah, that should be 507.86. And then it's G and minus 2. And it's given that the sphere is perfectly spherical balloon. So therefore 380 should be equal to 4 over 3 pi r cubed. So r cubed should be equal to 380 times 3 over 4 and then times pi. So that gives us 90.718, and then square root, technically cube root, and then over here, so that is r should be equal to 4.49 3 meters. So therefore the total area should be equal to 4 times pi times r squared. Now that is 253.711. So therefore the total mass of the balloon should be equal to 503.711 times, this is 507.86 plus 66.5. Now that gives us, so it's this multiplied by 507.86 plus 66.5 Now that is, okay, this is in grams, so therefore we can say it's 145.721 kilograms. And that should be the answer to the question. And the third part, it says, in taking the mass of 2 passengers, gondola and rigging, to be 270 kilograms, calculate the initial acceleration of the balloon at sea level. Okay, so alright, so from the previous questions, we calculate the mass of the balloon, the mass of hydrogen within the balloon, and then we're also given the mass of passengers, so therefore we can calculate the total weight of the entire system. And to calculate the initial acceleration, we can just use the upthrust, and then calculate the acceleration from that. So first of all, the weight of the entire system should be equal to 145.721 plus the mass of the hydrogen, which is 32 point, this is 0.58, this is 1, and that is equal to 32.058. That is 177.779 kilograms, and therefore, what we can do is that the acceleration is equal to the total force, which is rho GV, and I think it's 1.23, right? The density of air is given, 1.23 times the mass of the entire balloon, assuming that, the volume of the entire balloon, assuming that we neglect the volume of the passengers, and then that should be 380, times 380, and then times the gravitational acceleration, which is 9.81, and then minus 7 point, oh sorry, this is 0.779, and then times the gravitational acceleration, which is the weight of the balloon. Oh sorry, this should be the mass, and then divided by the total mass, so that should be 1.779, and then so therefore the initial acceleration should be equal to 23 times 380 times 9.81 minus this, and then times over 177.779, and that gives us 15.982 meters per second squared, and that should be the answer to the question.